So if you'll notice on the very front, there's a URL. All of this code will be posted online tonight to check out from GitHub. If you're familiar with that, pretty popular source control tool. So the whole reason I kind of came up with this set of lessons is I really like the 2GS. Every year I see people do amazing things with the Apple IIe here, and I think that there are quite a few programmers here who are probably a lot better than me. And they seem to really focus on the 2e, and I'd like to get more people into the 2GS. And so this is really kind of geared towards that. There's a little bit of expectation, if you looked at this, that you can kind of read assembly. If you can't, that's fine, but what we're really going to cover is the bare, here's what you got to know if you're trying to make a little game or something on the Apple IIGS in assembly language. So we'll talk about how to talk to the graphics hardware, and then how to launch from GSOS desktop into your program and quit back without screwing things up. And then if you come back on Friday, we'll get really deep on, not really deep, but further where we'll talk about playing sounds, playing music, and try and wrap it up with some mouse input and make a little game. So, for today, I'm going to guide this from here. If anybody hears me say anything that's completely false, let me know. And finally, I should probably introduce myself. I'm Dagan Brock, but that's on the front too. I'm much more interested in the Apple IIGS than I am myself, so that's all the introduction you're going to get about me. Sorry, I'm not as interesting as the Apple II. So, let's start with the first page, and I'll actually go ahead and let's play along with Merlin. I'm going to use Merlin today. Your other big choice for assembly language programming is Orca, and Orca definitely has some advantages, particularly if you want to bring in some C code and make your life a little easier, but for what we're doing, Merlin is great. It's my favorite, actually. I think it's a lot of fun. It's my favorite game for the Apple. So, back in the old days, basically your Apple II days, predating the GS, you'd have really simple programs that you would kind of run or B-load from BASIC. And that's going to be this first program. This will be online. Okay. Can you guys see this relatively okay? Yeah. Okay. There's only one instruction. It's RTS, return from subroutine. The top stuff up here is all comments in Merlin, anything that starts with a star. This is a comment down here.
Should we have the lights? Would that make it easier to see?
No, it only goes off.
Oh,
so if it's hard for you guys to see, that's
fine.
fine. I can run it in the dark. I just don't want any weird makeout sessions. So keep your hands to yourselves. So I know this is really trivial and silly, but this is a legitimate program. I don't have to tell it where to start or anything. I can go ahead and, as it says, hit Open Apple A to assemble it. So you can see it didn't generate anything, and then it generated one single instruction, the 60 for return from subroutine. You need a 1-byte program, and if you wanted to, you could save that object code. Again, it's on this page by hitting O. And so I just saved something called quit. So that's, what you would do back when you were really writing Apple II programs. And then if you were, let's say, in BASIC, you can just do run quit, right? Hey, it worked. I assume so. It came back. So no, it did. Or we can go ahead.
Successful program.
Yeah.
I think I can write that one.
That's
I think it's bug-free, too.
I start with this because I figured start with the easiest. So there's a bunch of junk, but what's really important here is it assembled our program at 8,000, and sure enough, there's our RTS. So I'm going to skip on the ProDOS 8. We don't really need to focus too much on that. But it's worth knowing that I put it out there if you guys want to take a look at it. What I'm actually going to... So that first one was quit. Here's QuitHey. So it does a lot more. We've got some compiler directives. Again, like comments. These don't turn into code, but these actually do something. These tell Merlin different things, and I've done my best to comment them really well. So in a Pro.8 program, it typically expects it to start at this specific memory address. So you go ahead and compile it to start there. I set a name so that when I assemble it, it'll automatically save out our system file. I tell it what file type. Now this is new. I set an equate. So what this is this tells Merlin, hey, instead of typing out this address BF00 or BF100, that's kind of how I like to say hex addresses, go ahead and substitute that in anywhere I type MLI. So I hope I haven't lost anybody up to this point. This is kind of what I was getting at. If you can read a little assembly, that'll get you a long way. And then we just call the ProDOS quit routine. So this is the same thing as before, but we can't just return. We have to actually ask ProDOS to let us go. Because ProDOS has some special types of quitting. You can quit to a different program. I don't really remember all the ProDOS 8 quit methods, but you guys can look that up in a reference. And essentially, you tell it to quit, and if there's an error, well, it's actually never going to get here because quit pretty much always works. So let's skip over ProDOS 8 and go to the next page on your handout. It's quit 16. I'll do this on the IIGS.
I'll come later.
The real deal.
You may want to share.
And honestly, I'm so glad I did this. This is the hardest thing. I mean, having the skeleton program just to quit. So if you have some assembly experience and you don't know where to get started to make a GSOS program, this is your shell program right here. Okay, everything right here after this PHK PLB, you can write whatever you want in here, kind of like you would a ProDOS 8 routine. So if you guys are looking for an empty program to start hacking away, this would be a great one. Now, right now, all it does is quit. So let's go through it real quickly. We have another new compiler directive. This tells Merlin this is going to be relocatable code. GSOS programs can be loaded anywhere in memory. It's not set in stone because maybe you've run 3 or 4 different things before you ran this program, whereas last time you ran it off a fresh boot. So you never know where you're going to start. This lets it be loaded anywhere in memory. Kind of like the ProDOS 8, we have a disk command that tells it, here's what we want to name our link file, and it'll also name our final executable similarly. The next thing is a little different. So again, because we're loaded anywhere in memory and we don't know where we start, the first thing you have to do, and don't worry if you don't really get this, but the first thing you have to do is set the data bank to the bank that your code is running in. Right? So GSOS loads your application and hands over control to your program. The first thing that the program is going to do is run whatever instruction comes to right here. Well, it's PHK. I'm pushing the bank that the code is in onto the stack. And then I'm pulling it back as the data bank. So if I didn't do that, maybe it's got the data bank set to another bank. And the next thing I want to do is, let's say I have some table down here called table. And it's got something like this. And I go, oh, well, I want to load whatever's from table. Well, if I have it set to some random bank, it's just going to load from wherever in memory. So you always want to set the data bank first, and now it knows, okay, if I do a load table, I'm doing it in the same place where this code currently is. This is a simplified version. If you write really big programs, you might actually have to split it up across multiple banks. We're not going to worry about that. If you get to that point, you've already mastered all this material, and hopefully you'll be able to figure that out. But for now, just know that when you start, you need to do PHK, PLB. Just take my word for it. And like I said, even if you don't understand what that means, so for now, that's how you start. And then this is similar to the ProDOS 8 quit. We have a ProDOS 16 quit. You jump to a specific vector, and then you define the parameters for what call you're going to do.
Are there any registers in this machine?
It's really the same layout as an Apple IIe, except a lot of the registers are also able to be switched into 16-bit. There are some extra registers, and then they have some odd behaviors because you can switch them out of 16-bit mode, so you can take, say, the X index register and load a word value that has 4 hexadecimal digits in it, like 0, 1, 2, 3, and then you can switch it down to 8-bit mode, and it's going to hold on to the 2, 3. 0, 1 hasn't disappeared, but it no longer knows about that. And if we get time, I could even show that with the
I was
debugger.
wondering, this is an entirely different environment than 360 assembler. You used to always save all the existing registers, put them in a place before you went into your code, your routine, so that at the end of it you would restore the values from those registers back to the registers before you turn control back to calling the program.
Right. So a lot of times people will do that.
360 assembler.
An example of that would be if you want to talk about the data bank register that we're affecting here. If you did something like this, so what I'm essentially doing here is I'm pushing my data bank register, pulling it into A, and then storing it somewhere for later. So if I wanted to, I could go ahead and recover that at the exit point. So we don't have to worry about that here. Most of the startup and shutdown is really taken care of by just calling this at the end and making sure you don't do anything to corrupt the stack, like too many jumps without JSRs without returning. So the other big difference here is that, so for the first program I hit Open Apple A to assemble it, and then I save the object file. The Prodos 8 one kind of saves automatically. This one I hit Open Apple O to open up this command window, and I type link. And this is going to assemble and link it into a GSOS program. And this is all stuff that I hate because it's just it's not collected anywhere in one place. These are all the steps you have to do, right? So you have to link it, right, to create your executable. You can see Merlin shows us our symbol table, no big deal. So let's just make sure that that did indeed work. Oops. And we sure have a 16-bit program. And it's going to be as uninteresting as the others, but hey, we didn't crash the computer, so again, I'm going to assume it worked. We are the champions of the day. So that's going to be the last kind of really trivial example. It's just these quit programs. Now you know how to get into a GS program and exit out of it. So we're going to start getting into the graphics and see if we can get through all of that today, because that's the fun stuff, right? So if you look on the relevant video registers in memory bank 0. So the 2GS has a different set of graphics hardware. The main thing we're going to talk about is this third one on the page called the new video register. We're going to skip over a lot of it because what's really important here is that setting this high bit 7 to 1 turns on the super high res mode, 320 or 640 modes. So that's all I'm going to say about that whole page. This is good for a reference, but that's really all you need to know from it. The second bit on there, linearizing the super high res memory, we'll get into in a little bit. But basically all that means is that when you, unlike the Apple IIe, when you write to the super high res memory, it just goes in a line. And you just write byte, 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 byte. There's no screen holes. There's no weird shifting. The only difference is that you get 2 pixels per byte, or alternately you can think of it as 4 pixels per word. So even though there's no dedicated sprite engine, you can, with one store operation, store 4 pixels to the screen. So you can get pretty efficient. And just storing obviously isn't the only way. There's some other tricks like relocating your stack, but we're not going to get that crazy in this little foray. So I'm going to go to this first super high res program, SHR1. You'll see it looks kind of like that last one. I added this in to let it know that we're starting in 16-bit mode. So here's all you need to do really to turn on the super high res graphics screen. I actually switch back to 8-bit mode here for the accumulator, because if I stored a word, it would store it on C029 and C02A. I'm not supposed to do that. I don't know what's in C02A, but I try not to corrupt memory. So I switched to 8-bit using this command, loaded 81 in the accumulator, stored in that new video register that's on this page, and then switch back out. Because I try to do as much as I can in 16-bit. I would encourage that practice if you want to write games. Then I just wait for a key. I'm going to actually skip down to that. The wait key is what you recognize from 8-bit Apple, right?
Yep.
So this memory location should look exactly the same. The only difference here is, again, I go to 8-bit because I only need to deal with that one, and I have to do a long load because, again, I don't know what bank I'm in. I'm probably not in bank 0. As a matter of fact, I can pretty much guarantee I'm not in bank 0 because the memory manager's not going to get into that bank. So I load it long from bank 0, but it's the same value that we're all looking for. And again, this is just a simple wait loop. Once it goes high, I fall through, and I can clear the keyboard strobe again using a long store, set it back to 16-bit, and return it.
One quick thought. Is there some reason why you're using 0 instead of D0 for your bank?
The ROM routines will come back, get mapped from ROM into 0.
For where here?
Yeah. For shadowed.
Oh, is it in shadow?
Well, and you don't have to switch back to 8-bit mode if you're going to do it. You can just do the long call into E0. And then you don't have to switch.
Oh, I don't know. I didn't really think about that. So no, I mean you're right.
I
So
was just asking if there was
please, that's exactly a good point, though. Please don't take this as the canonical way to do things. I am certainly no authority, and these are not the best routines. So I've kind of cobbled a lot of this together. Yeah.
It looks good, but I didn't see a need to switch back to 8-bit mode when you can access directly in the E0 ROM instead of the 0 ROM.
Well, I'm still only concerned about a single byte value.
Yeah.
I could load it and AND it off, which I've also seen a routine that does that, but then you still need to store to the strobe, and I don't know if you would want to do that in 16-bit mode.
Yeah, it wouldn't hurt.
So, entirely possible to rewrite that keyway routine another way. And honestly, some of you may consider using the event manager, which is a GS tool set. I won't go into it because it requires a little bit deeper understanding of the sort of event ecosystem in GSOS. But yeah, there's a lot of ways to spin that cat. I mean, the key routines in this are not what I want you to focus on, though. I more want you to think about basically what I'm doing to the graphics memory. Even this is a bit odd because there's a lot of ways to turn on the graphics screen. A lot of times you'll see C1 instead of 8.1. Depends on how you want to linearize it. So I wait for a key, and I'm actually going to have to pause here to show you this guy. Sorry for the difficulty in getting this on the screen and getting it readable. But the entire super high-res graphics screen resides essentially in bank E1. You can turn on shadowing to bank 01. And what you have is starting at 2000, the pixel data. And this is actually the pixel that is at the top left of the screen. If you look over here, I kind of mapped it out. So 2000 is actually up here. 2001 is next to it, 2002. Then we get all the way up to 9CFF, which is the bottom right of the screen. Okay, off of the screen, there are some other things that control how it's displayed. There's scanline control bytes. There are 200 of those, one for each line, and that's kind of represented over here. So for each line, you can set a scanline control byte. What do these do? They control whether it's 320 mode or 640 mode, so you can actually have mixed modes on alternating lines if you want. Don't know how useful that is, but you can. If you wanted to have nice text on one part of your screen and graphics displayed somewhere else, maybe. Certainly these have been used heavily for the guys that do the sort of demo effects, right? So another big one is picking which palette. So you put 0 through F in here, and you pick one of these 16 palettes. So that means any line can have a different palette from the one above it out of a choice of 16 palettes. There's also things for generating interrupts. I'm not going to discuss that, but if you needed specific timing to know when you hit a certain scan line, this is the guide you would use. And I'm also not going to talk about the color fill mode. If anybody wants to talk to me outside of here, I have a lot of great ideas on how to use color fill mode, but it's a very awkward mode that only lends itself more to sort of neat tricks than to useful interfaces. Basically, in color fill mode, you will write one pixel, and it's going to keep copying that pixel to the right side of the screen until you change colors. So that's what we have for the screen memory. 2,000 to this area, which is 7 CFF bytes. This area, which if you'll notice, it only goes from 9000 to 90C7, so there's actually a little gap in there before it goes to the color palettes. I don't think that memory is used for anything. It's pretty much safe to overwrite it, but just consider it a little junk data. And then the palettes themselves look like this. There are 16 of them. Each one has 16 colors, and the color is a word. It's 2 bytes long. So you've got green, blue. This one is always set 0, and then red. So if I stored FF0F, that would be the color white. If you think about the sort of hexadecimal colors that you would see on a web page or something.
Instruction be loaded at any address, or do they have to be on like even addresses or addresses divisible by 4, or is there any rule like that?
There's no, so the instructions for your actual code are going to be determined the same way that you would for the 6502, so that's all controlled by a program counter. It just ticks up. You can set the program counter. If you're talking about the limitations for screen memory, there are definitely some idiosyncrasies there. But I maybe don't understand the question.
Well, in kinds of totally different environments, so maybe the question is irrelevant. But in 360 assembly, you had to have certain things on full word boundaries, half word boundaries, double word boundaries.
Nothing like that. You just incur the same penalties that you would on any of the other 6502s for things like branching across page boundaries. You incur an extra cycle hit. If you're doing certain... One big one that I don't really talk about here is when you do long loads, obviously that's another one, but anytime you're using 16-bit accumulators or index registers, you incur an extra cycle penalty. But hey, 2 bytes.
It's usually worth it.
Yeah. So overall, you should get a savings.
Basically, still like another
Right. And then it does invert the bytes as it stores them in, but that's because that's the way that the 6502 family reads them back, kind of last in, first out. So, do you guys have any questions about kind of the video display? I wish I could graphically display this better, and if you want, I can hack around on an emulator and show you some of this. But otherwise, I'll go back to the examples, and we'll just start getting into how you write code to do some graphics.
So the screen memory is one-for-one. It's not jumping, or it's not interlaced, or it's just
right. So it really is just a linear map. So that table of memory.
So yeah, 2000 is where your 00 is, and then 2000 and what's that? 160.
So that's good though.
Whatever. 160 is an app.
It helps to see this. So if you look at, we're going to run that SHR1 program. So if you look at the SHR1 program, I guess I'll include it. Yeah, it's a little warm.
Do you have an electronic copy of this handout somewhere?
I will be putting the same information up on the same GitHub. So I'll have the code in one directory, and then I will be putting the presentation because it already needs updates. I've already found printing errors.
Yeah, I'm
and
sure
bugs and all
the
that
KFest site would host it as well if you want to take
Okay,
it.
good. Yeah. So it definitely will be online too, and maybe I'll go back and clean some up, or even do something a little more structured as a set of YouTube videos.
More copies. Or is it unsafe? Okay, if it's unsafe, I'm sorry.
There are. No, I feel really bad. They gave me this room, and I thought, well, I see 6 chairs. I'll go ahead and put together 10. It's like optimistic.
And don't worry about it.
There are lots of people in the other room, actually.
Here, do take this, though. This is the current one we're looking at. I'll see if I can get another. So, in that last image, we looked at the memory map. So I want to show you this quick clear screen routine I wrote for the GS. And this is, I call it clear naive, because this is really the naive way of thinking at it. We're going to start at the first pixel, right? We're using an index register.
Right.
The really awesome thing, if you guys are coming from 8-bit, is having a register big enough to only have to use one register. And to not have to, to be able to address the whole screen memory with one register. Oh man. When I did that little KFest demo, I was like, yeah, I forgot about all this work. So you just load this one register. It's going to be big enough to fill from the bottom of the screen up to the top. Actually bigger, so we don't need to go all the way to the end. I'm going to store zeros in there. And then I start a loop. I'm just going to start at that 2000 location, event V1. You increment by 2 because remember we're storing a word value, so increment, increment. And when we get to the very end, which there's 8,000 bytes, it should clear the screen. So the thing to note here is I'm overwriting everything. I'm overwriting the pixel data, the scan line data, and the palette data. This is not how you would really write code, right? You will normally don't clobber everything at once, but again, this is kind of a trivial example. So looking at it a separate way, I wrote a second routine that does the same thing, but at this time I start at the top. Well, one from the top. If you add 2 to this, it would be 8,000, but we're starting there. And again, we're going to store zeros, use the same index, but we count down. You could use a BPL, BNE, but basically you avoid this comparison. I'm not really going to talk too much about optimization, but when you think about the GS screen, that's really its big limitation. You've got about enough cycles to maybe store up to 1/3 of the screen in one 60 Hz refresh. So if you're doing anything that's going to affect the whole screen, you want it to be really fast. But I would say generally don't worry about optimization. Worry about if you're making a game or something, worry about making it fun, which has very little to do with optimization. I mean, it's great if you're running at 60 frames per second, but if it's no fun, who cares? So again, this is a kind of trivial example, but I'll use the first one because it'll perfectly illustrate the linear map of the screen. If you're familiar with Merlin, you can actually execute things from within it by using this command, since we already linked it. Okay, so I turn on the graphics screen, and then I'm waiting for a key. What's there? What used to be there? The 640 by 200 screen left over by GSOS. This is, this is my Max cursor, not the GS cursor on here. So I'm actually going to pop into a really awesome tool that you guys should get if you want to work on the GS. It's called GS Bug. That's not it. I can hit the right key on it. Okay, so this is a great debugger. If I open up this step window, you can see, oh, yep, there's our key weight routine doing what it does. Let's go ahead and just skip over that. We'll go back to where we were. Oops, I skipped one too many. I think if I do PC equals so I accidentally skipped where I set it back to 16-bit mode. That would have been bad if I continued executing. So Anyway, if you saw that, I actually changed the program counter to go back up above. Just ignore the man behind the curtain because I shouldn't have done that in the first place. All right, I screwed everything up. And that is why it's so much nicer writing this stuff on emulators. Let's try that again without skipping through everything. Okay, so we're back to that first clear screen routine, right? I set the index to 0. I load 0 in the accumulator, and we're just going to start storing it out to the screen. Another nice feature, if you hit S, we're going to go to the SHR screen.
How did you know where in memory to look for that code? Was there an org that I did?
Oh, so what I mean just now when I went into Debugger. So I actually hit, what is it, Command, Option, Control, Escape, which says GSBug, come up now. Like it listens for that.
Okay.
So essentially you're forcing an interrupt.
Okay.
It breaks
So
right
it
there.
breaks
Your
where
program
it
counter
is.
is where it was.
Nice.
And I just happen to be at a good stopping point because I happen to have a key weight routine there. You could have thrown in a
Oh,
break.
yeah. I forgot the keyway routine. Yes.
And I
Okay.
commonly throw in a break too. So if your program does crash and you have GSBug, you go to GSBug instead of the monitor, which is a lot better for debugging. So you can hit S or T to go back to text, and I could hit space to start looping through here. I can also hit return to start letting it loop through fast. So you can see it's going to start. All right, so this is going a lot slower because it's tracing through, but that's literally writing from left to right. The other thing to note here is that the bytes aren't swapped like you would normally expect them. So if you have a 0 for the very first nibble, it's going to be 0. It's not like shifted or flipped anywhere. It's completely linearized in this mode. So if you write 0, 1, 2, 3, it's going to have pixel 0, pixel 1, pixel 2, pixel 3. I don't know if that's clear enough. But either way, my overall, the thing I want you guys to take away from that is that if you've done any Apple IIe graphics, this is going to be so much easier for you. Still has its limitations. Okay, but we don't need to, oops. If I hit G, it'll resume execution. So that's the simple clear screen routine. I'm going to do one more and then, well actually, how are you guys feeling about all this? Do you need any more on the screen clearing type stuff, or would you rather I jump to, I have two possibilities. I could go into drawing text on the screen, or I could go into loading images and drawing those on the screen.
I put text, but
I go to text and
Okay, so this is not in your handout, but it will be, and it'll also be online. The best way to look at this is actually to look at how I've defined this. I made a simple little font engine. I don't know if you guys can kind of make out any of these, but we'll start with A up here. Yeah. So these are the pixels that I'm using for my little font, right? And if I actually, let me do this. This will trash my source code, but it'll make it easier for you guys to see for now.
Ooh, cool.
Okay, so you can see I've changed all the zeros to underscores, right? Now this is only really using two colors. I have 0 and F, but if you had an E in here, this is basically what a sprite would look like if you were just defining it in a table. And if you come back on Friday, we'll actually do some sprite examples with multiple colors. But for a font, I just made a quick bitmap font that has pixels basically in color F or color 0.
you hand made these, or did you this from a library or something?
No,
You just ASCII.
I probably did this when I was 17, but I was
Yeah,
like,
yeah.
I'm not going to make a new one.
Okay, so
I
it is
don't
a
know.
library. It's just one you made.
Well, I rewrote all the code for it though. So, but I took the hex because I didn't.
Yeah,
I'm
why
sorry.
do that?
I have a kid. I
Yeah,
don't
right.
have time. There's no way I would have gotten that done. So what I'm doing here though is really just making a simple table where I can load that data and store it directly to the screen. You don't have to do any translation or anything. I'm just going to say, if I want to draw a space, I'm just going to draw these zeros in a line. And if you look, each character is 8 pixels across, which is 2 words, right? So I could basically store one line of each character with 2 16-bit stores. This is going to be relevant when we actually look at the little routine. So the code that's online that actually uses it, oops. I wanted to show you how to use it, but I also wanted to give you this routine because it sucks when you first start playing around and it's hard to debug stuff and you want to just put something on the screen. So if you want, you can just pull this right out. All I do here, if you look at this, I'm going to find my string. So I make a string down here, a little KansasFest. The str command actually means that it precedes this string with a length byte. This is the ProDOS way of making strings. I just did that to make it easier. If you want to print out a ProDOS path, you could do it using this little font engine. So all I do is this. All right, 3 commands and you've got your own font engine. So please feel free to take advantage of this. All you need to do is include my little engine. I say, here's my string, hello string. I want it on line 60, y60 times 160. Remember, you get 2 pixels per byte. Each line has 320 pixels, so half of that, taking out that 2 pixels per byte is 160. So 60 lines down and actually 60 pixels over, same reason, bytes. So let's go back to that little font.
Now, one thing you may want to point out to people unfamiliar with the super high res screen is when you're in 320 mode, you get 2 pixels per byte. But when you're in 640 mode, you actually have 4 pixels per byte.
That is a very good point, and that is not illustrated on here. So when I show you at the bottom here how the pixel mapping works, imagine it being half that size, because he's right. In 640 mode, you get a...
So either in
different
320 or
memories.
640 mode, you still only have 160 bytes per line.
Yes, that's exactly true. So in 640 mode, it uses the exact same memory space. You just get fewer color options. And then there's the dithering that we're all kind of familiar with that gives you an interesting appearance of some more colors. So if you are going to do 640 stuff, please be aware that that's not contained here. So I don't want you to be confused because this is similar but a little bit different. So thank you for bringing that up. So those 3 commands will draw a string. Let's look at what the actual code to do it is again back in this font engine that I got caught cheating because I wrote part of it when I was a kid. Okay. So I tried to, and I'm sorry I haven't covered this very much, but I try to make a lot of use of variables when they make sense, which are compiler variables. They have nothing to do with the GS processor or anything, and also with local labels. The reason I use a lot of local labels and variables is because assembly language doesn't have namespaces if you're a modern programmer. So you can only have one drawstring, and I won't get into it, extern and linking, but you can only have one drawstring across your whole code base. And you're like, well, that's not a big deal, but trust me, you will eventually think that you don't have something called exit this way, and you actually have something called exit this way. And so these lines that start with a colon like this, these are local labels, which means it only exists from a real label until it hits another real label. So if I tried to call...
Is that an assembler thing? Is that
this is Merlin. So if I try to do this... not done, it shouldn't work because essentially it's not defined within this code little region between 2 global labels. So this is called not done, but what these are normally called, and this is where you're going to really need local labels, is loop. I mean, how many times are you doing loops in assembly? Constantly. So it's nice to be able to have loops that are just local to that little region, and that's generally why I do it. So the variables here are similar. Again, I could have just done this. I could have just said, make them just normal variables, or normal defined spaces. But again, I'm just trying to keep my namespace clean, and being a little anal retentive here because it is a library.
What does the square bracket at the front of it, what significance does that
So it means
carry?
it's a variable, and the difference here is that if I define this, and I set aside 2 bytes, I can't later on have, well, now I want this as that. It'll say, no, you've already defined that. But if I do this and this, that's completely appropriate. So how does it know which one to use? Well, which was the one you used last? Okay, so in this case,
It has to be between those 2 real labels you mentioned.
no, not the same. It doesn't have the same context as the label. These can exist across big swaths of your program, but they can be redefined. I'm slightly abusing them here. I think the real reason they're commonly used is for macros. So let's say you have some speed loop you want to unroll, and it's going to store at screen pixel 1, screen pixel 2, screen pixel 3. You could have a macro that every time the macro expands itself, it increments that and uses a variable.
They're like a temp label.
Yeah, and you know, the real guy to talk to on that is our man, Mr. Breeden, and it is in here somewhere. I should have kept that up. So here's kind of their example. See how he's got 2? He's got this thing called JLoop, and he loops here. Well, then he redefines it down here, so you can reuse it. But yeah, sorry, I don't know. I'm not very good at explaining that because, like I said, I even kind of.
is JLoop plus 1?
What's that?
Could you redefine JLoop as JLoop plus 1?
Yes. That's the thing I thought he had a better example in here somewhere.
So that's kind of the real power of it, is that you can, like you were saying,
And solving
increment
your
pixels
scroll is a
or whatever.
JLoop too.
Well, there's one on there. Well, he reuses it there, but then that's the real power is you can basically do special operations with Merlin, so you can do addition. It's outside of is outside of the logic of the program, and you can't do that with just an equate or a label. You can't change those values once you define them. Whereas with variables, you can, and you can say, okay, well now it's equal to what it was, but it's equal to that plus 60. So go ahead and generate code based on that now. So it affects it in the compiler, but like I said, that's not exactly how I'm using it here, but the really awesome, they're compile time variables is what they would be called.
I'm missing some of the names of labels on the list.
Oh,
That's his computer.
Oh, I'm sorry.
that's all right.
Sorry.
No, you're fine, you're fine. So, go ahead.
How are you getting your syntax coloration computer right now?
What's that?
How are you getting the syntax coloration on this?
If you want the syntax highlighter,
Yeah,
it's
I do.
if you look at that GitHub URL, you'll probably see this awesome dude who's so radical and awesome.
Wow. Awesome.
So he also wrote a VI plugin that has a syntax file, and this is based off of a different syntax file that was floating out there. I just added some Merlin keywords. If somebody wants to contribute to this, I'd love to get Orca and other assemblers in there. I did it for my own personal needs. I love Merlin so much, I have a really hard time editing in an 80 by 25, 24 editor.
Yeah.
Because assembly is an inherently vertical language, and the last thing you want is a screen. You want you want a screen that looks like a door. Right. So we've all kind of got our different solutions. If anybody wants to know about some of this stuff, I have sort of a script that just does some translation for the spaces and the line endings, and then it uses Apple Commander and some other things to create a little bundled disk image that I
I was
use.
wondering how you were doing that.
Where can you get a hold of Merle?
It's available on whatever the big FTP, one of them. Yeah, Asimov.
Just Google for it. It's fine.
Look for, I think I looked for Merlin 816, and I also covered that in a YouTube video recently. I'm going to start trying to do that because I feel like maybe if I...
Can you just add that build script real quick?
Sure. Let me make it a little smaller. It's not as confusing as it looks, and I could have actually made it a little cleaner. There's a couple of special things here. I call these specifically because I actually translate. There's a music file on here, a PackBytes picture, a Sprite file. But for everybody else, it just goes through this loop, and it converts the line endings using this tr command to a temporary file, and then it reads it in as a text file, which seems to be close enough. Then in Merlin, there is one little gotcha, if you care, and I'll try and also put up a disk image of these sources, so that if you guys don't have a good way to do these build scripts or whatever, and you've got an emulator, you don't have to dork around putting it on there. And I'll fix this, but if you'll notice, I probably already fixed that one. Some of these spacings come out wrong. Merlin has a command called fix, which sometimes will fix those for you. So again, it's kind of like the link you hit, Open Apple O or Command O, just like link, but there's another command called fix. I don't know what all the other commands are. Got to check the Merlin book
I
for
thought
that.
you loved Merlin.
I do, but you know, I know so little, and it's
Merlin knows so much.
we talked to Randy today and Stephen Wozniak, and I think what brings people back to these machines is that I'm getting better, and I am still very new to this, and I haven't mastered it, but it's one of those things I feel like I can do.
Mm-hmm.
I'm a very good programmer for my job, but I can't master a modern computer. No single person can know everything about it. And we program in languages that try and abstract it away from us. And I work with so many guys that are much better programmers than me, but they really don't have a good core understanding of what's going on at the hardware level. Most of the time that's not necessary, but it can be a little frustrating when they don't get why certain things are important.
And why certain things don't work and they can't figure it out.
Yeah. Or try to do something garbage collection. It's like, yeah, so back to our font engine. I'm sorry if I skipped over this,
No,
but
that's-
I'll try and put this up there. I tend not to share this stuff because it's always a copy from an old project, hack it to fit the new one. It's never a really generic script that I feel like, oh yeah, you guys should all use this. It'll probably confuse you if you're good enough to already do some of those commands on your own. You write one that fits your needs and instead of hacking one.
Essentially, though, I was about to ask you. So, how do you get this from there to there?
Yeah.
But now I know.
Well, and I'll check Sheffy's work, but I think next year I'm going to try and work on getting some better integrated tools, maybe either with the GS port team, because that's really the hard thing, and I don't know if he wants me to reveal it or not, but Olivier, Brutal Deluxe, he obviously did the Mr. Sprite stuff, and I don't know if you guys have seen any of that, but it actually has a Sprite compiler in there. He's taking that out a step. He's working on a full compiler, so hopefully I can work with those guys and we'll get some really solid cross-dev tools. He's doing them in Windows. I've already ported Mr. Sprite to Mac, and I unfortunately haven't had time to give him the back port for the Mac stuff, so it's not out in public. But I think this year I'm going to take a step away from programming the Apple II and start programming some Apple II tools, because this is the final step, right? All of us want to be able to use our fancy VIs or whatever, and our fancy VI editor that's older than the Apple II or whatever. But yeah, so I would be also happy to share or discuss or anything, those little scripts I have outside of here, because I have obviously a lot of custom stuff like that. So going back to where we were, we have these variables and I've defined them. And the first thing we do when we get in here, and I'll go ahead and put the calling source side by side with this, you can see that's too cramped. But if you remember, I had those 3 lines. The first line is a pointer to my string, so I store that in this stir pointer. The X, sorry, that's the accumulator. X was the current position on screen, so it's the top left part. And as it goes through drawing your screen or your string, it's going to update the current position inside this routine. So I just kind of keep track of it right when I start, and then I set the character index to 0. So we're going to start at the first character, loop through, draw all our characters.
You didn't want to switch
It's
to
an indirect to grab the first character.
Yeah, all right. I was like, what am I doing? I forgot. So the strings, remember the first byte of my string, hello KansasFest, is going to be however many characters that is. So it'll be like 19 or something. So I pull that off so I know how long my string is, right? That's how I figure out how long I need to loop. As you pointed out, I did it in 16-bit mode because I save switching in and out. And I just mask off the top character. kind of goofy. And then I store it at our length byte. So you might already notice I've kind of been cheap here. I don't support carriage returns in this font engine. I have another one that does. And you can only have up to 255 characters in your string, because I obviously mask off anything higher than that. It won't work. Apologies, but this is, again, just to kind of get you guys rolling. So we've got our length byte. I store it in length. And then we go through a loop. The loop goes through and grabs the next character, which right now it starts with 0, right? We compare it to the end, which is very good because a lot of people don't do this. And then you get a 0-byte string, and they lose their mind because they didn't think about the fact that somebody might be really mean and call them with an empty string. It happens. Somebody will do it, especially if you give your code to someone else. They'll do it if you don't.
Or they have 256 bytes, right?
Right, yeah. I don't know if I checked for that very well.
When you mask it off. So,
Yeah. I'm trying to think if there's anything weird there. Yeah. If somebody made a longer string, this could fail horribly because it doesn't really know. It would chop off your string. So, so basically, all I do is I say, all right, let's start with the character. We start with 0. Are we at the end? If we're not, then keep going. If we are, we've finished drawing our string and we can return it. So here, not done. It's not a very good name. What this actually does is gets our next character. First, we increment the character index. We load it into Y. The reason we do this is, remember, there's 1 byte at the beginning, so it actually starts at 1 on this. I don't modify the string. We're going to skip over that.
So technically, you can only print a 254 character long string because you're using the 0 index as the length byte, right?
Yeah, but it's only a byte. So you still have
Yeah, but you.
Otherwise, it could have been 256, but now it's 255.
Yeah, because you don't ever use character index 0, so you're only using the other 250.
Right, all right, which is 255 though.
Oh, I see what you're saying. But if your length is set to FF,
if it's
and you hit there, then it's going to quit. It's not going to actually run through again.
Yeah, so if you actually did FF, yeah, that would break it too. See? You already looked like that. That's why it's tricky. That's why assembly is so fun, though, right? It's very exciting. So that's a euphemism for a lot of things. It's exciting when it runs. That's why Merlin's my favorite game. Anytime anything assembles, I'm like, yeah! And then if it actually runs, even better.
I'll get crazy.
Yeah.
And the loop module's your high score.
Yeah, pretty much. So this is, pretty simple. I get the next character using a DirectPage. I've stored it here, and in case you didn't catch that, this stir pointer, I actually set it to 0, 0. And what I'm really talking about here, is DirectPage 0, 0.
Is that evil?
Hmm?
Like, which parts of DirectPage can you use?
All of it.
All of it.
All of it.
The
So
DirectPage.
JSOS gives you your own.
I totally did not mention that. Same as your data bank and everything else, you get your own DirectPage and your own stack in GSOS.
Cool.
you can still access stuff in Bank Zero DirectPage. It'll have some of the similar variables that you would expect to see there, depending on what's loaded in the system. But
And your direct page can move anywhere in Bank Zero.
they're relocatable too, and abusable in that sense, or exploitable. I shouldn't say abusable. There's nothing wrong with it, but I'm sure Sheppy could tell you about the exploits they use for things like stack-based animation, where you map the stack to the screen. Mr. Sprite does that, I think, as well. Where, so basically what you get if you do that, you can do push effective address, right? Which says push this number, 1, 2, 3, 4. Well, if you relocate your stack on the screen, you can just keep pushing effective addresses, and it's going to automatically update the index, shave off a couple cycles. A lot of work to write routines that do that, so again, it goes back to, do you want to optimize for that?
Then that's when you can do the unrolled loops and stuff to get extra speed, because you can do an entire line and then check to see if you're at the bend of the screen yet. So you're only doing 200 compares versus 200 times 160.
So ultimately, you can get really crazy deep on that. I'm not that good at it. I'm aware of most of these techniques. I find that most of the stuff I do, I try and design around the hardware and what its capabilities are. So you can draw a lot of sprites on the screen without any slowdown. You can make puzzle games without any slowdown. You can make action games that do not scroll. You can make action games that scroll. I mean, if you play Rastan, but those are very difficult games to write. They definitely used all of the tricks. They used sprite compression. They used stack-based screen updates, shadowing, you name it. They put it in there to achieve that performance. So if you get there, good for you. I'd love to see that someday. Hopefully I'll do that someday, but it is a lot of work, and not every game requires that. A lot of games you can go with the naive implementation.
Just looking forward to Mega Cycles 3D or something.
No, gosh. I shouldn't have brought that one back. I should have rewritten that. I feel bad about that.
I love Mega Cycles.
Yeah, it's so buggy though. We'll get into that.
Can't have everything.
Yeah, ROM 1 versus ROM 3, there are some differences. Yeah, that's the best thing, right?
The box was excellent.
So anyway, going back to our routine, I load a character, I mask off the high byte, again, just staying lazy and keeping in 16-bit mode. And then, this is weird, unless you've written font routines, I subtract space. Why would I do that?
Because the letter A is the next letter after space,
No, these
and it
symbols
gives
are.
you the index.
Let's look at my font table. I didn't define everything everywhere. I defined from space on. You're going, okay, well, that still doesn't quite clear it up. Let's see if I still have this guy up. Hey, you've seen this before, right? Okay, this is an ASCII chart, jerks. Okay. So this exactly matches the table that I made. I didn't put everything in there. I made characters that started at space, went linearly through memory, right? Just going up number by number. I don't know where I stopped. I think I stopped right here. If I tried to do a lowercase letter, it wouldn't work. But anyway, I defined a table that starts with space. So how do I know which character I want to draw? Well, I get the next character from my string, I subtract space, and then it's going to be an index into a table, except that this table is, like any table, these are words. So to get to the next guy in the table, you actually have to multiply it by 2. So this is the same math you guys have probably seen in other places. If you shift your byte, right, it's going to put a 0 in the low bit. And now we've got our real index into the table. So we've converted the letter A into a pointer that points to where that little grid of characters that makes up the A is. So that means we have the location of our source data that we're going to copy to the screen. And that's all this is doing. I mean, it's all about trying to find out where's the data for that character, and then I'm going to copy it to the screen, rinse and repeat.
You've made a lot of reference to just staying in 16-bit mode where you can. Having not done 2GS programming, is that in contrast to switching in and out of 8 and 16-bit mode all the time, or what?
I don't know. I just know that when I wrote stuff as a kid, I had no idea what I was doing, and I just would constantly switch out. Because if I was taking a source example that had an 8-bit load,
Right, and
I've got to do an 8-bit load, and I was not sophisticated back then. Chances are it doesn't really matter, right? And again, if you're doing it when you're doing a key weight routine or something like that, if you're doing it in a graphics loop, there's probably something wrong. With some specific exceptions, Mr. Sprite would be something that addresses that. Where if you're going to have to write a byte 2 pixels out to the screen, and you're trying to mask it against the background, it's better to just write that byte than it is to load that word, mask off the mask area, combine it with your pixel data, and store it back. Does that make sense? If you've done Sprite stuff. I'll actually get to that, so I don't want to confuse anybody by that conversation, but that's one example I can think of where it legitimately probably
I
makes
was
sense
trying to
switch
suss
it.
out, like, is it
Same
Same
with
with
this.
this.
It's a matter of style, and this is the hard part. I don't have any mentors to work with on this stuff. You know, like the guys that were getting paid to do this aren't really interested in it these days. I think it's those of us that weren't able to do it professionally, that didn't get burned out on it to the point where we want to learn that.
Yeah.
So I'm not. Very
And
good
it's
on
an
the style
optimizing
guys.
thing, right? It's in some cases it's better to go into 8, and other times it's better to stay in 16.
Yeah.
It's
So from my standpoint, I do try and
Case
keep
to
it
case.
16.
Effort and pain.
Yeah.
Because the one problem that you'll start to have is when you switch into 8-bit mode, and you forget.
right?
Or you switch into 8-bit mode for a routine, and then you forget when you add a 16-bit routine after it, or maybe you just relocate some code in your code base, right? You go, oh, this is annoying me here. I'm going to put it at the end, forgetting that your compiler thinks that needs to be compiled in 8-bit mode. And you get this crash, and you're just looking around for where you did it, because you know, I left a rep 30 out there, or whatever, or a 730 out there. And that's the thing. I will choose the naive way to do things, or make it more readable, just because I know at the end of the day I'm so good at doing stupid things, and it's more of a protection against that than anything else. So once we've got the actual location of our character, I just transfer it to Y. I load the current screen position into X, and I call this draw character routine. If you remember, I said we could do each line with just 2 stores, storing 2 words. So I wrote this out by hand, just to show you that you could. What you would normally do is you would probably use an index if you were drawing an N width sprite, and you'd say, if my sprite is 16 pixels, I want to count until I get to the 4th word, and then add A0, meaning 160 bytes to get to the next line. I didn't do that here. I wrote it out longhand because this is already kind of showing you some slight optimization. A font might be somewhere where you would want that if you want to write a lot of text to the screen. It should be kind of fast. So just real quickly, we get the address of the font data. Right. So we passed in the table offset. We look at that font table to get the real address of where the data is. What am I doing here? I know there's
You're
a reason.
subtracting the address of the beginning of the font data from.
Oh, I know why I did
So
this.
that you can index on.
Yeah, I
can
hear
index
you.
again.
Thank you. Yes, this is kind of some goofy indexing because I didn't want to use 0-page pointers. So I subtract, because I don't know where that table landed, right, the font data. So what I did instead, I said, well, I'll go ahead and get the address of that, but then I'll subtract it so that it's 0 indexes that table. Right, and then I can always point to that table, the font data, plus my index now. So if it's character space, then this Y is going to be 0. If it's the character that comes after space, this Y is going to be however many bytes after it, as opposed to the actual location. I kind of regret this because I don't think this is the clearest way to explain it to you guys for Font Engine. I'll try and bring a sprite routine on Friday that I think would be a little more generic. But it's basically what it is. I'm using 2 different indexes, so 2 different pointers, but all you need to know is that I load 4 pixels of font data from whatever character. I store it at the screen offset. I do it again 2 bytes over, see, font data plus 2. And then I store it 2 bytes over on the screen. This is kind of weird syntax for Merlin's sake. Then I load the next character, or the next 4 pixels from font data. And you'll see we just keep doing that, right? We keep going up 2, 2, 2, because that's all linear there in memory. But when we get to the second line here, we add 160, and 160 plus 2. This is line 3. 160 times 2, 160 times 2 plus 2. Line 4, 160 times 3, 160 times 3 plus 2. So basically I'm saying, load from the table, store here on the screen, load from the table, store here on the screen, and then keep going on the load table, but store in subsequently different positions on the screen. So we go dot, 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 until we get to the end. And that's it. It just returns back. It says I've drawn a character. The last thing this guy needs to do, he knows that he needs to update the screen location by 4 bytes. And I just do 4 increments. I could have used an add carry. So that's it. That's my little font routine. And again, if you just want to do something cool like that, all you need to know is that you can include that and call these. Create a string, you load the pointer to your string in the accumulator, you load where on the screen you want it, you call draw string, you're done. It's going to draw both the black and the white pixels. I'll make another version that masks that out if you guys want it. But enough talking about it. Let's just at least prove that I'm not completely full of it and this does work. So if you saw, it created all those references to each one and put that in the table. And if you compile it, if I took more time to show it to you, you'd probably get that a little better. All right. So I didn't go over some of the code in there that actually sets the colors for us. So I set color F to white, color 0 to black. That's about it. So that does indeed work. And just to prove a point, I then drew the screen with color 1 and drew this again to show you that it is not getting masked off, right? So it's always drawing what's behind it. By masking,
have a transparent color. Yeah.
Right, I mean there's no transparency there. That would have to be addressed by, normally you just use ors and ands. So you load whatever you want to mask it against. So if you have a picture on the screen, you load the screen data, and you say, oh, well, I want to draw a dot there, so you remove that dot from the screen data, and then you put your dot on top. Yeah. You remove the dot by using an and with an inverse mask, and then you OR it with your actual data.
Yeah, it'll slow down the routine because you end up having to read data, merge them together, and then write it, rather than just writing it.
Significantly faster, but it has that drawback of you can't make it transparent. But yeah, not everybody wants to do masking. Mm-hmm. Just depends on if it calls for it, basically. And in a lot of games it does. In some it doesn't. You don't need masking in Tetris. Everything is square. There's nothing behind it. There's nothing in front of it. You're drawing squares. You just make something like this. So we started late. It's kind of already at an hour, and I feel like people are probably itching to relax or do something else. I have more material here that I can do today on loading PackBytes images, if anybody wants to do that today, or kick off. It's up to you guys. I mean, I could go all night. I've got plenty of code here that has been untouched. We haven't talked really much about the scan line control bytes or any of the stuff for effects, but
I'd actually like to. I just don't think I will. I don't think we'll go.
The question is how much will you retain tomorrow morning?
Yeah.
Yeah, and that's again why all this stuff is online. Well, it won't be there if you check right now, but it will be momentarily. And if you do come back, I promise.
Well, before everyone leaves, I have a question
Oh, I do have one
that I would like to ask everyone.
That's Spectrum Cobalt.
which is, does anyone have a USB zip drive?
One of my resources.
You do.
About 10
May I borrow it, please?
I think, yes, I do. Yes.
They say that,
USB.
I forgot one other thing, if I could.
I'm doing
grab
weird
your
things.
attention, because I wasn't going to do this because I don't like plugging stuff, even though it's free. I released this today. I don't know if you guys saw it. It's a silly iOS app, but it's a 6502 and 65816 instruction reference.
Oh, I
Is there
know
an
that.
Android
That's a good
version?
awesome.
What's that?
Is there an Android version?
All the data is there. I really wish I could have done an Android version first. It's just so easy to do this stuff. So I do plan on doing that, and I would like to expand this out and include things like toolbox calls, memory maps, and make it available on the web too, with things like autocomplete. So if you guys don't mind trying to check that out, it's a good reference, and it does. Oh gosh, I don't even have my own store version. Oh, there it is. Sorry, I had to buy it off the store yesterday. It also does show you which processors these commands are available on, so if you're just coming into GS programming, that'll make it a little easier for you to spot the ones, but I wouldn't take it as super scientifically accurate. I've started to fill in the data on the timings and stuff, but appreciate it if you guys check it out, because I would like it to eventually become useful. I would work on an Android version. I sent something out on the KFest mailing list, and it's called Recreate with an A. Sorry, it's a horrible name, but the original name was 65XX Programmer's Reference, and I just thought, man, no one's going to find it. So I had to at least give it a name that I could tell people.
Recreate with an
I could call it like Recreate 16 or something.
And I was going to do that, and I thought, semantically, I'm the only person that cares. Even though the whole reason I'm a big proponent of the 16-bit stuff. So,
Well, no, that's why I was surprised you didn't.
yeah, I think if the hardest thing in programming is picking a name. It's no joke. I mean, just take that time. 3 days, 4 days on naming it is nothing, because
What you name it is critical to whether it goes over or not.
Really, yeah, exactly. And that's why I couldn't go with 65XX Programmer's Reference, even though
Some people would get it because
that's specifically what it is. Well, the other thing is, I have this grand vision that eventually it'll have the Apple IIe, 2GS memory map, maybe Commodore, Atari memory maps, all the toolbox calls, all of the registers for all these different systems.
Oh, pinch
And
to
then-
zoom memory map. What a great idea.
Yeah, I'd love to do that stuff. So,
Are you around tomorrow? Or are you just going to
no, I want to come. I think for the whole day tomorrow. I don't know if I can stay too late. So
I may ask a question.
yeah,
All right.
and I'll try and put some of the build script stuff up there too, just in case. But I don't know.
All right.
It's all a mess. Thanks so much for your time, guys.
Yeah, if I can get a copy of that to hand it.
Yeah, have a